A very warm evening to one and all. Honorable Chief Guest, Mr. Rohan Sharan Sir, respected Principal, Dr. Pramod Patil Sir, respected HOD, Dr. Bhavna Ambudkar Ma'am, past Chairman IETE, Dr. S.R. Jokes Sir, Faculty Coordinator, Dr. Dipali Saleh Ma'am, all teachers and my dear friends. I, Swagata Dere, on behalf of the entire committee of IEEE, IETE and TESA, welcome you all to today's webinar on the topic Blockchain and the Future of Internet. Ever since the invention of blockchain, the Internet has gone through a lot of iterations. It has revolutionized how effectively the Internet can work. To tell us all about blockchain and its future, I would like to introduce to you a guest presenter for the day. He is a co-founder and managing member of Timechain Labs, a blockchain expert who holds a graduate degree in Industrial and Systems Engineering from IIT Kharagpur. He has worked on projects related to blockchain and Bitcoin. He also backed first position in Blockchain Hackathon of Technology Festival at IIT Kharagpur. So without further ado, let us please welcome Mr. Rohan Sharan. Over to you, sir.
Good afternoon. Thank you for having me. I'm going to walk you through what I've learned in the past 5 years of being involved in this space. We start with me telling you about what blockchain is, how it is digital paper, how it behaves as digital cash, how it powers the new data economy, how we have smart wallets, we have a huge explosion of on-chain applications, and the vision is to have the whole new internet powered by the blockchain. So it becomes a fundamental protocol at the level of HTTP. This internet is called the Metanet. We are going to have the IoT, the Internet of Things, being built, connected to the ledger, to the blockchain, transacting data. I'm going to tell you about the latest developments of tokens in this space and end with the final vision for India that Bitcoin and blockchain can provide us and how you can get involved in it. So let's begin. My journey started in college when I got my first Bitcoin as a prize money. And then I found out about all the properties of smart contracts and the future of it, how it solves many of the problems that we are plagued with on the internet. Then obviously I got deeper involved in the space and ended up starting a company called Timechain Labs, which focuses on on-chain application development. Why do we call it digital paper? If you see, paper has this property of leaving a trace, being tamper evident. So we are reproducing that property into the digital environment. That's what blockchain does. It solves the Byzantine generals problem that I'll get to in a moment. Public wall. That's what is the best way to think about the blockchain. It is a public wall in which anyone can write on it and anyone can read from it without having someone as a guardian who is guarding the wall and deciding who gets to write and who gets to read, controlling the connectivity between people. So if you don't have that, you have a direct peer-to-peer interaction between each other through that public wall. And the reason I'm calling it a wall is because it leaves an evidence trail. It leaves a very strong, unchangeable, immutable. Immutable means not mutable, cannot be changed. It's like a endless public wall which is getting extended since 2009. Every 10 minutes, a new block of the wall is added, and that's how the wall is getting extended. There is a demand for writing on the wall, and there is production of the wall. So miners are ones who are producing blocks of wall every 10 minutes. So every 10 minutes, we have production and consumption of ledger space. So another word to use is called ledger. Also, we can call it time chain, as I like to call it, because Satoshi, the creator of the blockchain, called it time chain. He never actually mentioned the word blockchain even. He always called it time chain because what we have is a immutable record of events that happened in time. So it's a time chain. Market power is democratized in the network. So like Facebook is there, which has a private database. Twitter is there, which is a private database. Then they provide connectivity to each other, but in exchange, we lose power. We don't earn from our data. We don't own our data, and the terms and conditions are all dictated by that private entity, which is Facebook. And it benefits from all the contributions of all of our data and all of our interactions instead of us benefiting. What we are provided is just connectivity to each other. That's all. So what blockchain does is by default it provides the connectivity by just providing the public form that anyone can openly read and write on and access and trade, use control over their own data and earn a lot from it. As we go on through the slides, you will see what I mean. So how was this digital paper created? It's done using proof of work, which is the innovation behind Bitcoin, which created the blockchain. Bitcoin is an economic system which creates this marketplace for block production. Every 10 minutes, there's a new block of wall added. So these miners are in a cooperative competition to produce the next block. Why is it cooperative? Is because each miner requires other miners to build on top of their block instead of someone else's block. So they are trying, once they make a block, so what they're doing is listening to all the transactions that happened on the network across the 10 minutes, which are not already part of the chain. They group it into a block. They have to do some work, a computational puzzle, a hash puzzle to iterate to find a number which satisfies some difficulty criteria. This is done in order to make it have a difficulty in convergence, create a hardness. This hardness makes sure that we have convergence onto a single chain. Otherwise, this is a problem in computer science. The network listens to every transaction at different times and it distributes away. We want convergence onto a single chain. So this type of economic system creates in game theory what we call is a multi-leader follower stackable game. Stackable game because we are building blocks on top of each other. Every miner is a leader who needs other miners to build on top of their blocks, so they are followers, and they need other miners to build on top of their block. So it's a multi-leader follower stackable game, and it's competitive in order to earn bitcoins, which comes from transaction fees or the new bitcoins that come into circulation every 10 minutes in a new block. So the first transaction of the block gives some amount of bitcoins as it comes into circulation, but the more it comes into circulation, that amount gets reduced. And it's like a subsidy which is given in the beginning to bootstrap this industry, this economy. But once it is already into circulation, you don't need the subsidy to sustain this. So it bets on the chances that there is going to be people to demand making transactions on chain, and you can charge transaction fees. So that's what miners earn from. They earn from transaction fees per transaction. So miners are in a competitive network to produce blocks, and this, because it's a competitive network to earn money, is evolutionary and adaptable. It evolves because other miners can provide a better service, faster transaction, better services, or faster hash, more hash power, more network connectivity, and they can outcompete you. So you have to keep investing and keep becoming a better business, providing better service to people. And that's why it's always alive. So you don't have situations happening like you have in, like, Twitter went down for 6 hours a few weeks ago. In Bitcoin's history, Bitcoin has never gone down because the blockchain is maintained by multiple distributed set of miners, and they're competing. So even if you as a miner go down, there are 100 other miners happy to take your place, happy to take your money. So it never goes down. It's always alive. There are some misconceptions I'll walk you through regarding. Oh, first let me walk you through what was there in the image. So this is a chain of blocks you see. If you go on what'sonchain.com, You see tal.com produced a block which is building on top of SV pool. It was a 670 MB block. Then you have a 244 MB block. And that's how the blockchain is getting extended. And this right now. So this is called a block explorer, where you can explore the blockchain, all the transactions that are happening live. So misconceptions. There's a lot of misconceptions, which I have learned because I've been in this space for quite some time, which you will fall into too. So the first misconception, which I was believing for a long time, is the scalability of blockchain. That blockchains do not scale. That was a fundamental problem, because what we had till 2017 in Bitcoin was the block size. Every 10 minutes we have a new block, and the block size was limited and capped, suffocated kind of, to 1 MB only. It's like, imagine email SMTP protocol got developed and it was suffocated to 1 MB across the whole internet in 10 minutes. So only 1 MB amount of total emails can be transferred in 10 minutes on the internet. So that really suffocated. But it's not a natural part. It wasn't a part of blockchain by default. It was supposed to be, that was the Satoshi vision, was supposed to be have a marketplace to produce blocks. So in which we have miners decide, the producers decide if they can produce the block or not. And what happens is actually we have economies of scale. When you scale blockchain, you scale the block size every 10 minutes, then each transaction in the block becomes that much cheaper because you have economies of scale. And that's what comes to the next points, which is transaction costs and transaction time. Sorry for the background noise. The transaction costs are reduced because, again, every transaction, the more you scale the block size, the cheaper it becomes for every single transaction. So right now on Bitcoin SV, which is the Satoshi vision version of the blockchain, the Bitcoin blockchain, which follows this model of scaling the block size. It has 1 paisa per transaction. It's super cheap. Otherwise, what we have is a transaction cost problem with many blockchains, which is like multiple dollars to pay for a single transaction. It's ridiculous. We cannot have internet money or data economy or casual global payments made using such transaction costs. And we have instant transactions. Because again, if you look at the economics of this network, what is happening is you just want a guarantee that a kind of probability, it's always probabilistic. Whether your transaction is the one which is going to be settled on the final chain is always a probability. It's never going to be 100%. So as long as you have an assurance with the miner giving you the assurance that this transaction will be settled, you're good to go. So we have instant transactions. We don't need to wait for, that used to be the case. We used to wait for 6 blocks, which is 1 hour, to wait for a single transaction to accept it as done. But it's supposed to be instant. So that's what we have. We have actually instant transactions, instant settlement. There's this huge one about private versus public security. So we have this kind of development of private blockchains that have come up. Private, this is what happened during the time when internet was coming up too. We had, sorry about that background noise. Yeah, we had different private companies coming up with their own protocol for internet, and that defeats the purpose of the internet kind of. If you have your own intranet has its uses, just like it behaves kind of like a database. You have your database, which is private. Again, it's private, it's permissioned. But the nature of the blockchain and the internet is to be public. Internet, because it's all about connectivity. And connectivity becomes the most public. The most public you are, the more connected you are, is the more you part of the internet. That's the same concept applies to the blockchain. So we have the entire security model, in fact, of blockchain is to be public. What you're doing is broadcasting the transaction to as many people as you can, so that maximum amount of work is done on top of your transaction. So it's like you're announcing that, oh, this transaction happened right now. Listen, with the loudspeaker, and broadcasting it as far and wide to as many people as possible, or at least as many people with capability to produce blocks as possible to add work to the blockchain and settle your transaction. So that's the security model. It's to be public as possible. So the being private completely defeats the purpose, and also it loses the property of it being the kind of immutable paper that it's supposed to be. Because if you don't have this kind of a work that is back, oh yeah, that's where proof of stake comes in. So we have this private. So if you lose the proof of work model to build blocks, then you fundamentally lose the very property that makes blockchain valuable, which is the immutability of it. If you don't have work done to produce blocks, then it's super cheap and it's just a matter of talking to people and getting the blockchain changed. So without doing any work. So it becomes a matter of community consensus to change the blocks, change the records. So it doesn't behave as the immutable paper that it's supposed to behave like. That's the valuable property of it. That is only created using proof of work. And in proof of stake, what we have is proof of stake is a consensus mechanism that was created to solve this scalability problem that proof of work supposedly had, because the block size was limited to 1 MB. So what proof of stake does is, as I told you, in the tip of the chain, there are multiple miners competing to become the leader, to be the producer of the next block. So in proof of stake, what we have is the most invested people, the stakeholders, that's why it's called proof of stake. The stakeholders of that network who are invested into that network get to vote and decide. And there are many fashions of this, like they have a round robin fashion to decide who is going to be the next block producer, because they have the maximum stake, maximum number of points. So they just get to be the block producer for the next block. If you look at the economics of this, it creates a kind of oligarchy. Why do I say oligarchy? Is because you're not, because you have money previously, a stake previously, is why you are getting to make the new block. But that's not what happens in pure economics. In economics, you have to be the best service provider to the network in order to keep your business going. Just because you have stakeholder, you're a long time stakeholder with a lot of coins, you don't automatically get new coins, even if you provide shitty service. That's what we have. That loses the evolutionary adaptive nature of the blockchain, which always keeps it alive. That's why what we see is proof of stake blockchains. Many times the blockchain just dies because the one who was supposed to make the new block is not online, because there's no incentive to be online that much. He's not having to really invest and put money in to make sure that he earns money back and be competitive on the marketplace. So it's basically a community is sitting and deciding what's going to happen. So obviously we have a lot of problems that's created with that. So what we have is different blockchains are there. So my company uses the BSV blockchain, which is the Bitcoin blockchain, which has removed all the limitations of block size and scaled it. But there are also others, which is Ethereum. I briefly mentioned about it. And there's Hyperledger, which is a private, more of a permission blockchain, and also R3 Corda, which is also a permission blockchain. So I already discussed how permissioned or private blockchains have difficulties of their own, just as They're not part of the internet, more of an intranet. That kind of thing is happening over there. And we have trust basically involved. So it's not actually behaving as the immutable blockchain that we need without trust, more of economics to secure it. And then we have basically scaling capacity is still limited. Unless you have this economy of scale going on a public blockchain done by proof of work, you cannot have a blockchain that actually works to give you the vision of the internet running on micropayments and transactions, a lot of transactions happening, every single data packet behaving as a Bitcoin transaction, like following the protocol. So that amount of scale, that vision of the internet where you don't rely on advertisements but on direct peer-to-peer micropayments for all interactions is not possible unless you have super cheap instant global transactions at scale. Only then that's possible. So this transactions are still not possible with that scale in a neutral manner, trustless neutral manner. Okay, digital cash part of it. That's I just gave you a little bit of glimpse about what digital cash property of it is. What I mentioned is micropayments. So what is micropayments? Micropayments is payments, global, instant, which are of an amount less than a paisa. That's a micropayment. Why do we need it? For a very small amount, it opens up a whole new arena of business models which run on you earning through every single interaction, your contribution, every single data, stack of data that you provide. And that the value of that is very, very small. But at scale, you earn a lot. Imagine the number of likes Twitter, celebrity Twitter on Twitter gets. It's like at least in thousands, 10,000 on a single post. That also happens very easily. So if they just earn 100 cents, then not 100 cents, 1 cent on one like, that gives them 1 cent into 10,000, $100 with just one tweet. At scale, they earn thousands of dollars very easily. We already have a competitor of Twitter which works on this. It's called Twitch, and we have every like has real value, real Bitcoin transaction with a small value attached to it. So you cannot spam it by creating multiple accounts and multiple likes, because you have to actually pay money for that like to count. And there's actual value there, and that's how you also earn money. You earn a lot of money. So there is a real economy and real pricing of what is really valuable. So we are not lost in a maze on the internet where what is valuable we don't know, and it's getting dictated by advertisement and advertisement agencies driving our attention. So the business model completely changes once we have real valuing of data and interactions directly. And the same, I'll walk you through the various applications which also run on data, monetizing data, and that's how it behaves as an informational commodity. And that is will be very interesting. So what we have is that every single data packet, when it follows the Bitcoin protocol, it functions on the level of TCP, the Bitcoin protocol. And we have a whole vision of internet in which in the browser you will see, instead of HTTP, you will see Bitcoin : // and the website name. And that website then is powered by a Bitcoin protocol. The data packets that you're exchanging with the website then is following the Bitcoin protocol. And what we have is you sign in with your wallet just like you have emails right now, like you sign in with Google, and then you have that sign in with Google there, and then any transaction, anything you do is Google gives the profile pic and some other data like username and other details. Just like that, we have wallets behaving as our control center. Like that's the next topic. Wallets behaving as the control center, and you sign in using your wallet to every application, and then you do transactions with the application. You interact with the other people on the network for that specific application, and you transact not only data and interactions but also in value, small amounts of value globally. So you have a whole information economy going on, native to the internet. So what your wallet is it's simply literally what your wallet is. What does your wallet do? It manages cash, notes of cash, right? So you receive some cash in some transaction that happened, and you refer to it and say that I want to spend this right now. You received some 100 rupee note 10 days ago, and then you want to spend it right now. And what your wallet does, it simply manages those notes of cash for you. So that's what it is. That's what in Bitcoin also it is. It's the digital wallet which manages outputs in Bitcoin transaction. So Bitcoin transaction has outputs and inputs. So when you spend Bitcoins, what you're doing is you are combined, just like in paying someone 150 rupees. You take input of 100 rupee notes, 100 rupee notes, so those become 2 inputs, and then you give out 150 rupee note to someone and 50 rupee back to yourself as change. So those become outputs. So your wallet is simply the person who received that 150 rupee note. Now his wallet shows him that he has 150 rupee note. His wallet is managing that output. So wallets care about those outputs. They are just managing those outputs that they can unlock. So what is happening is these outputs are actually scriptable. You can customize those scripts holding those Bitcoins on those outputs with every transaction. And they are simply managing those outputs such that they can spend it in some future transaction. They just have it, just like your wallet has a list of cash notes that it can spend in some transaction, in the future transaction. It's just holding on to it. That's what your digital wallet also does in Bitcoin. It simply keeps in memory the transaction outputs that it can spend. It has the ability to unlock and spend by signing. That's a traditional standard Bitcoin transaction in which you give a digital signature to sign and you get the ability to spend it. But you can also create custom scripts. So this output script, it's a scripting language which is Turing complete, and you can customize the script to create any kind of custom block, like demanding any kind of information for it to be unlocked, any kind of stack of information to be unlocked. That's where the interesting part comes in. The interesting part is that's where it starts behaving like an informational commodity, because what we have over here in the Bitcoin protocol is a stack of data which should satisfy certain criteria for the Bitcoin to be unlocked. So when I'll go through it in the next few slides. You'll get what I mean. It's going to be very interesting. So and also, just like we have rupee cash notes printed on paper, which is a commodity, just like that we can issue central bank digital currency notes, also government notes, and any other kind of just like we issue government notes on paper, right? We just stamp it and it becomes a government note. So it's just the Bitcoin protocol. The layer just behaves as a commodity layer for this chain of value, a chain of it for the paper-like nature of it. And on that you can have different type of tokens issued, different kinds of government notes for it to behave like CBDC, which is central bank digital currencies with multiple denominations that can come apart. And let me walk you through the misconceptions. There are many in this too. This is the most interesting one. Blockchain without Bitcoin. Is that possible? Can you have proof of work without blockchain? No, because you want the paper-like property for it to be immutable. And you cannot have proof of work without the incentive to work, because you are doing investments to expend work to buy the transaction with work in time. So you need the incentive system, the economic system to have this convergence of the chain onto a single chain with proof of work. So you naturally have to have Bitcoin. So Bitcoin is what powers this value-based. It's fundamentally, the blockchain is actually a economic system. There's no encryption in Bitcoin. It's all public. So it's not hidden or private, and it's completely traceable. And the word honest money is mentioned 14 times in the white paper. So this whole notion of crypto and it's not traceable and not compliant is actually all false. All the rules, all the laws we have currently with commodity and all the other laws, security laws and other laws we have, international payment regulations we have, anti-money laundering and AML and all, is all applied equally to Bitcoin also. It's not something that's out of it. And it's actually the most legally compliant creation ever. There's actually a paper written on this. And but it has been changed. The protocol the creator made has been changed. So right now, what is believed to be BTC ticker symbol is a kind of a changed protocol which is not behaving on the vision of Satoshi. There's a report by a consulting agency on this, MNP agency, that talks about this, how Bitcoin, which we say is BTC, is actually not functioning as a protocol, it was envisioned to be, it was made to be by the creator of it, and it has been suffocated at 1 MB and a lot of other problems. Account versus cash model. So what I was telling you about was each output behaves as a note of cash, right? So that's the cash model of it. This is the blockchain which functions on the cash model. It behaves as peer-to-peer electronic cash. That's the title of white paper of Satoshi, who created Bitcoin. But we also have an account-based model. In that, notes of cash, your wallet doesn't have a total sum of all the amount, and it tells you, okay, you have this much, right? It's a layer on top of it, account. An account just gives you a number. It doesn't have individual notes of cash and individual records of each being separate, each amount of cash being separate and totally independent for processing. It's a different model. In account, you simply have one number, and that one number has to be edited and changed. This creates problems. So Ethereum follows this account-based model, and Bitcoin follows the cash-based model. Actually, it's probably the only one which follows the cash-based model, and with some other ones, Litecoin probably, but not a lot. And most of us follow account-based model. But the problem with account-based model is that it's not parallelizable. Each output of cash can be independently processed, independent of other outputs of cash. So it's all completely independent. So it's parallelizable, and it scales. Horizontal scaling can occur. But in account-based model, that's why Ethereum has a lot of scaling problems. In account-based model, we face a problem of not a lot of transactions can be done. Acid problem of data is also very well known. Not a lot of transactions can be done on the same number, parallelized, because it's all dependent on that number. So some other application must not be using the same number, and there are many other problems. If I go into the complete, that will need a whole another video. There is this notion in BTC, which is called top coin, and the current crypto market, that it's just store of value and we just use it as an asset, and you just trade and flip it, and it is not used in commerce for payments, actual payments, and actual as a commodity, or it doesn't have any utility, any use. So that versus the notion that it is an informational commodity to be used to enable the whole global data economy. That's what it's supposed to be. So that is a completely different vision than store of value and flipping and getting other people to invest and just flipping to increase the price without any use and payments. There are other coins that you can see in comparison. This is the website Coin Carbon Cap. There's a good comparison of different proof of work currencies by energy efficiencies. In BTC and other proof of work currencies which are suffocated in block size. So block size is suffocated means the number of transactions per second is suffocated. Because in 10 minutes you have only one block, so in 10 minutes you have only that many transactions. So that many transactions, and you have the price increasing. So you have more work done because the incentive is there for miners to compete for that. So a lot of useless work is getting done for something for each transaction because it has not scaled. So once you have this, because in BSV, let me show you, in a scalable blockchain, which is BSV, Bitcoin Satoshi Vision, we have the scalable blockchain, which is proof of work based, and per transaction, the amount of work that is getting done is minuscule and is getting reduced even more as it scales, as there is more demand. So per transaction, proof of work is actually the most optimal system. It's more optimal than any other system. It's actually hyper efficient at scale. It cannot be more efficient than that because it's hyper competitive to be efficient if it is allowed to be the protocol vision of Satoshi that it laid down to be. So let's go on to the very, very, very interesting part, which is the data economy. So as I was telling you, when we make a standard transaction, we make an output. So that output is actually demanding, you're putting a demand for someone to provide you a stack of data that satisfies a script you write in the output. In the standard transaction, in the standard Bitcoin transaction, what we are doing is we are writing the standard script, which is demanding the stack of data, which is the public key and a signature. If someone provides the public key associated with this address, which is a hash of the public key, and the signature, then the Bitcoin is unlocked. Then that output can be spent by the person who unlocked it by providing the correct input. Now this script was a standard script which was written to check this signature and whether this address belonged to this public key associated with that public key. But this script is actually a Turing complete script and it can be customized to make any kind of information lock. Any kind of information lock. So in that manner, it behaves as demanding a stack of data which satisfies certain criteria. And what is information? Information is actually data which is structured and made useful in a package which can be consumed. That's what commodity is. Commodifying something means standardizing it for consumption in a structured manner. Giving structure to data and selling it, like demanding it and having an economy for it, that's the information economy. So that's what Bitcoin enables. That's what the blockchain is supposed to function as, the transaction and data economy, and then also tokens as we go on later. So data is the new oil, and you must have heard this. And all of this advertisement powered internet that we have today, Google, Twitter, Facebook, and all of them, they take our data and also our attention. What they are buying, what they're demanding is our attention, and using our data, they're linking it to the proper advertisers to sell our attention to. But in the proper data economy, in which advertisement is not the only basis, in which we value data, information, interactions directly using micropayments, it's even more powerful. Data is even more powerful, and you wield control over your own data. We have value-driven pipelines of data which flow through transactions. All the interactions are actually Bitcoin transactions. Every packet is a Bitcoin packet. And we have a global micro economy of data flowing through those packets, those Bitcoin packets. We can, using these customized locking scripts, we can create financial instruments, exotic financial instruments that don't even exist, because we can customize the locking scripts to create all financial instruments that currently exist, as first of all, and we can apply those instruments at a micro level to stacks of data. And the business models that are opened up by that are going to be very interesting to see. And that's why we have an explosion of on-chain applications that are happening. All the problems that we have are solved using that. So that's the Metanet economy, which is the value-driven, value-based internet where you own your own data, you earn from your data, and you spend your money that you earned, and you keep earning from all the interactions. So it's like every day I receive a lot of money that I keep receiving, like ping, ping, ping. Instead of notifications, you receive money. Okay, more money, more money. And when you interact, you also spend some money. So it's a whole economy that is going on with interactions and data. And your wallet is the center for that. So we'll go on as we go on through the next slides, we'll see. So in this, it's not all surveillance based, in which your advertisement is it's all advertisement based, in which our data is sold. So it's not all based on that, and it doesn't have to be, because now we have the global micropayment methodology. Before we didn't have. Google actually had this problem. They actually wanted such a technology. At that time, we didn't have the native commodity of the internet to value data and transact globally. So that problem was unsolved. So this shift, it's not the ideal solution that Google was looking for, that they had to go in order to scale. It was a problem, but now it's solved. So things will be changing, and it will be getting much better. We can value information on the whole of internet by correct pricing of things. There is a price for everything, even if it's very, very small. Even if it's that very, very small, still it's relevant. And it matters. At scale, it matters. Because things happen on the internet in a collective, scaled manner. And if you can value things, micro interactions and small contributions, drop by drop, it adds up to a whole ocean. And that's how the whole internet is made. It's the most valuable thing. But no one actually sat down and just got a huge salary and made it. Everyone contributed small, drop by drop, and it happened. So with this, now it's supercharged. Now it's incentivized, and it's the original creators earn. Like every single page you load, you have a small micropayment from a wallet for the information that is getting sold to you as you're buying. So we have this on-chain, peer-to-peer, direct interaction-based internet, in which there's no middleman who is arbitrating things and then controlling the connectivity. So that also connects to the semantic web that we have, we don't have, that we're supposed to have, in which computers can also read what the page is supposed to be about, the meaning, through meta tags and all. So this on-chain internet, in which everything is transaction based, our wallets are the central control center from where we control things. There are a lot of applications which the wallets sign into, and as I told you, I'm going to tell you about all the applications that are there. Not all, because there are a lot, but I'll walk through. So there's this metastore.app, a website where you can browse all the applications made and running on the BSD blockchain. And there are a lot of interesting ones. As your electronics students, the most interesting one is Weather SV, predict ecology, and MetaStream. So weather SV is weather monitoring. You need your data. You can put up sensors anywhere. That's actually part of predict ecology, and then they together made this. So anyone can contribute the weather in real time and small bits of data, and they earn for their data streams that they give you. And anyone who's consuming the data stream of weather pays for the data stream. So we have streams of data. That's what MetaStream is a tool to actually monetize streams of data coming from IoT devices embedded all across in real time, giving you data for weather, for conditions of, let's say, how much rainfall happened in somewhere. So it's real time and it's on the ground, not you have reliability of many different pointers coming from the same place, all getting paid a little bit of money to keep the sensor alive over there, because there's an incentive to use that data. So that's how IoT is going to, Internet of Things is going to be embedded everywhere through this incentive to give sensor data from the sensors and then respond. Every action then comes. So the embedded devices would have, actually we have some future slide on IoT, so I'll get in more details with that. We'll have embedded wallets which connect with the blockchain and which connect with other agents. They're actually agents if you think about it. They're agents acting on your behalf, and then they connect with other agents who specialize in different things, and they share information, trade information, and make transactions happen on behalf of you. And so legally also it's already there. The law for agent law is already there. And then you don't need any changes for that too. Even the AI dystopia people talk about, that's even not needed, because we already have laws for humans, and there's no AI is actually conscious and making full agency. It doesn't have agency. So human actually makes it. Even if more highest level of complexity, it still has a kernel. You cannot get rid of the kernel. You can have some very sophisticated kernel or some very simple kernel which actually produces code or anything, but still it has a kernel. It will always have a kernel. In the end, it's very dumb. So it doesn't have agency. The one who makes it, the one who releases it, he's still liable for everything. And it's his agency that's acting. So that's just an agent acting on his behalf. So legally he's bound. So yeah, anyway, I was getting off track. Yeah, so IoT, that's going to happen. Transactions of data, large scale, earning, and agents interacting with other agents and creating data, and then acting on that data. Social media applications, what are they? Streamality is a YouTube competitor. In that, you sign in with your wallet and you pay per minute of watching, streaming the video, and the creator can set the per minute rate at which they want the payment. So that's an interesting application. Then there's Stretch, I already told you about, it's the Twitter competitor. There's Bitpost, which is about blogging on-chain and earning through your blogs, every page, small micropayments. So again, you're not tied into the subscription model for everything. That's the creator economy, they're right there, in which you're not tying everyone with subscriptions, and that doesn't even scale. To scale this market, you cannot have thousands of subscriptions. But the only way to scale is actually, in the end, getting down to transactions, only paying for what you use. That's where it has to go. So Powping is another social network. It's like Facebook, and then there's Relica, it's an Instagram, also Bitstagram, that's also Instagram competitor, Onchain, all of them. It's all incentive based. That's the nature of all on-chain applications. And also another property they have is that the UI can change. Other people can come in and make a better UI to interact on with other people on chain. There's no private database that's managing in the middle where your data is logged, and then you can be selectively censored or selectively what's that term? Shadow banned. Oh my gosh, I hate that. So that happens because, again, some political agenda of the private company in the middle, which our government was also struggling with Twitter for that, so they shifted to coup for it. So that all problem is there when you have a private database, and still the power is still there in between that you have to struggle with. But you don't have to struggle with it if you use the blockchain the way it's supposed to be. If you use a scalable blockchain, then you have direct interactions on chain, on the ledger, on the public vault, and that problem is solved. Then we have data apps in which you have a developer API marketplace, Godu, which was made by kind of an Indian origin guy, and API and me, another API marketplace in which data streams from the API, you monetize it using Bitcoins. Obviously, IoT apps are there. There are a lot of games, and games have a very interesting use case that they are also gambling. They are provably fair using the blockchain. Otherwise, in all games, is that you have the database owners or the owners of the platform. They are connected with some entities, and they have more knowledge than the users. So if they have more knowledge than the users, they can act beforehand or have selectively more advantage, competitive advantage. And so it's not, you don't know if it's fair or not. That's the problem that comes up with gambling, online gambling, and also many other games in which money is at stake. When money comes at stake, things get serious. This is a very serious problem. So blockchain provably fair gaming solves this. Blockchain solves this by using the chain. Haste has solved this. Yeah, it has a very interesting development with the on-chain leaderboards. And Crypto Fights is a game that was actually trying to build on Ethereum first, and then shifted to Bitcoin SV to build the game on-chain application. All the actions that you do in that game are actually recorded on-chain, and that's how the other wallets also read, and it scales. That's why they had to shift to actually Bitcoin SV, because the requirement was to have a lot of transactions at scale. So the high amount of fees would not make it sustainable on Ethereum. So therefore the problem they were facing. There's Omniscape XR, which is very, very interesting, and I see a bright future for it. It is mixed reality in which you have assets in the digital sphere which mix with the real estate in the real world, and you have economy of those assets, ownership of those assets in the virtual world. You can embed things from the virtual world in the real world, and you have complete mixed reality of this, and it's all tokenized, and you have a whole economy, a whole brand new world over there. That's also something Facebook is probably getting into with Meta and Oculus Rift. So we have a huge explosion of apps. If you go on those Metastore, that's what you see. That's just one screen, half of the screen of Metastore. There's a lot happening. What will be next? Smart wallets. So digital wallet becomes your control center, ultimate control center, from which you control your entire life. If we don't take an Orwellian bend in which we are controlled, all of our life is controlled. On the other side, there's this possibility if we implement things well, then we have everything private, we have privacy, and we have maximum control. The individual gains power. We are on a transition point at this point. And yeah, there's a struggle. So digital wallet becomes your identity. It handles your identity, let's say Aadhaar card or whatever identity you have, your passports and your devices controlling your fan, lights, etc. Of course, your keys, car keys, door keys, all managed, all our locks, all our managed through your wallet itself, and payments, of course. So your wallet transforms into a very small digital wallet. You don't even have to carry your wallet. It's all digital. So that's the future that's coming. You have automated transactions done on your behalf by that agent and interacting with other agents. You have smart locks. I have told you about this before. Smart locks, smart contracts happening. Here that you have signed on chain using cryptography. You have signed it, and you're liable for it, and you are also supported by it. You have tamper-proof records of whatever signatures and contracts you make on chain, and hackers leave a trace. Authentication tokens, once they come on chain, because they are also tokens, they come on chain, and every action you do has a record. It leaves a trace on chain. So it's still private, because anyone who reads the chain is not able to figure out what means what, because it's all gibberish. But the people who need to know it, because they have the links to link something, to link the data to what it's supposed to mean. They have the meaning. So the meaning is not written directly explicitly on chain. The meaning is off chain, and the wallets then infer the meaning. People can infer the meaning by themselves, because they have the relevant information for themselves. And hackers, then when you hack, you necessarily leave a trace, and you can then trace it back to why the hack happened, from where it happened. So because all actions that the hacker did was recorded, and it cannot be erased. That's a problem. That's a problem for hackers, because that's what hackers do. They erase their trace. Whatever you do, you erase the trace. How you came and all. But that's lost. Tokens. We can tokenize anything. All physical assets and all digital assets can be tokenized on chain and represented. Their ownership can be represented, the licenses, the rights, usage rights, digital rights management can be represented and transacted and transferred to other people. So we create a provenance of any object. Provenance means the history of the ownership, or the record of its even creation, and then all the transfers. So it has a whole history. So it creates ability to have post markets and pre markets. Post markets is what happens after the market, after it has been sold. You can have second hand markets, third hand markets, or recycling or repair. All of that is post market. So it's aided with having the tamper proof record of its past, which represents its provenance. We can have systems which create this trust then in the history of any object. So when you're selling it, you cannot lie about it. And same goes for on the pre-market side. We have the supply chains. In the supply chains, a component which is causing errors, causing delays, a vendor which is giving a batch of product that is giving the wrong component again and again, you can identify it if you have the provenance of all the components that are made to make a product. So you can have supply chain optimizations done using it. You can have coupons, tickets, all the financial instruments like stocks, derivatives, all represented on chain. That requires working more with the regulatory bodies to make it happen, but it can be done. You can have fractional real estate. It's already there. Many countries are working on this. Dubai has made the most progress on that part, and India already has fractional real estate ownership, but yeah, it's not that efficient, and using blockchain based tokens can make it more accessible and more efficient naturally, and it's all very simply linked to wallets and its tokens. CBDCs, as I've mentioned before, how outputs just like can function as tokens, like tokenized, and can function as CBDCs, central bank digital currencies. We'll have denominations issued of rupees, 1 paisa to 20 paisa. I don't know, 1 paisa. We can have new denominations issued by government, like Micropasa, that will be interesting. DAO, okay, so this is another thing that had interesting implications of what can be done collectively using the chain. So decentralized autonomous organizations are collective organizations that are bottom up, that are formed bottom up instead of being top down, led by some leader having some agency and hiring people and then going public, being private at first and then going public later on. That's the traditional procedure. But in a decentralized autonomous organization, what you do is they're trying to replicate the nature of Bitcoin as a evolving competitive organism, kind of. That's what organizations are. They are organisms. So you have a bottoms up organization which is public by default in the beginning itself. Instead of the private company going public later on, it's public by default and formally structured by default in the beginning. So that's how it begins. It begins by being public and it crowdsources all the funds, and it also writes its employees are also public. It's all public. So and they are all running on their own incentives. They're all individuals who are entrepreneurs on their own right. They're all entrepreneurs interacting. They imagine every person is an entrepreneur. Then how will they be part of a single organization? That's when you have these decentralized autonomous organizations, because all entrepreneurs are reacting on market prices and information. Once you have market prices and information which are reliable, then everyone has incentives to seek profit from optimizing things. So everyone in the organizations which are focused on some specific market, it just becomes structured on chain, the incentive model for it, and then people just see the incentives and take positions and act by themselves without any boss telling them something. So it's a very different form of organization which is bottoms up, and where everyone is an entrepreneur. That's a very interesting way things can progress. So yeah, I see those are initial coin offerings. There are coin offerings, many coin offerings. You hear this term a lot. Be aware. There is a lot of scams out there. Everyone is issuing their own coin. So you have to be aware. NFT craze, as I told you, current use case is only to do that. It's not digital right management has not yet happened. So it's just a unique representation of something unique that people have speculated. But it could hold some future value if it progresses. But the vision is ultimately to have a single ledger to represent all market activity so that it becomes hyper efficient. By having a single ledger to track and then have proper pricing of things and then react with the correct pricing of things. By representing with tokens, the real world gets attached to the digital world and you have huge efficiency gains and all kinds of capabilities that you didn't exist. So all of the properties that commodity paper offers, that's actually offered, like commodity cash offers, is offered by the peer-to-peer digital cash, that is Bitcoin, the ledger. What we have after that is, I'll just provide you and leave you with what is the impact of having Bitcoin and the Satoshi vision in India, what the benefit to India is. India faces a problem and also an advantage. The problem that it has is about the legal system, most of it. We are faced with a lot of corruption that holds back our productivity. And the legal system is not efficient or reliable. So what happens is the productive people, the most productive people are hurt. So that's why you see them going to other countries and doing quite well. But in India, it doesn't happen. It is changing. We are going up the ranks on ease of doing business, but we can make progress in leaps and bounds if we adopt blockchain technology. we can have increasing productivity and efficiency by using this ledger in government processes, creating trust by reducing corruption, because we have tamper-proof records of activities, and we have very efficient ecosystem, which is something which is a focus of government also in the next 5 years, the present government. So what we can do is have real-time reactivity from the legal system, and also there's a lot of reduction in crime that can happen, a lot of consistency and trust that's created with the public. So government in fact can benefit a lot. Because the word honest money is mentioned 14 times in the Bitcoin white paper. It's actually about having a trust ledger that connects society together. Beyond this, what I like to call Bitcoin is it is production centric. Instead of being consumption centric, what we have with the current economy is actually, it is very consumption centric. Instead of focusing on savings and investments and having proper investments in the right directions, such that we have long-term visions which win instead of short-term debt which wins, which is incentivized. We have long-term savings, conserving and investing well to increase the value. So that's the kind of economy that Bitcoin creates. As it is long-term focus, it's deflationary. Instead of being inflationary, it's deflationary. So it creates this production-centric environment instead of being a consumption-centric. Once we reduce consumption, it creates a sustainable economy which is long-term focused and involved in continuous churning and disruption. Especially for India, micropayments creates an opportunity to take advantage of the large population and the volume that we have to create massive wealth which has been untapped as of yet. Because if you see the internet, it's all made from small contributions. We have a huge web of information that's created, all from just contributions. But having micropayments power this, and having a real data economy to power all the contributions, to make them give earnings back to the contributions that were made, and have this economy going, it supercharges this. And what this creates is earning through micropayments, drop by drop, but at scale which we have, it becomes a lot. And the most important point that I love about the Satoshi vision is bringing power back to individuals. Instead of these platforms forming their own political power, even wielding power over politicians and political parties, which the government was also facing, with Twitter wielding power, its own power, and censoring people. So they moved on to Coup, a new Twitter competitor based in India. But the power still exists with the platform owners. Until you have the platform owners, the power still is there. Because you're not directly connecting through a fabric, the public wall of the time chain. You directly interact with people. You have a middleman, which always has power. If this inspires you to build this new internet and realize this vision of Satoshi, there are resources I can share with you to develop on Bitcoin, develop blockchain applications that can power this new internet. BSV Academy is a great resource to learn about how to develop on Bitcoin and the fundamentals of Bitcoin. At the end of these courses, you will get a certificate. There is a demand for Bitcoin script engineers who develop the outputs I told you about, and develop Bitcoin wallets and make Bitcoin applications. Besides that, we're also planning to have a workshop on on-chain application development. It will be taken by the author of a book, Bitcoin Blockchain Protocol for Micropayments. If you're interested, you can sign up using the form in the slide, which will also be shared with you. And which brings me to an end of blockchain and the future of the internet. I hope this inspires you to build on the vision of Satoshi for the new internet, powered by micropayments. Thank you.
Thank you, Rohan sir, for giving us the insight on blockchain, Bitcoin. We have a honor course for third year students on blockchain. And we are very fortunate that we got the recent advanced technology from, we listened from you, sir. Definitely, we will be having to listen from you in future also. Thank you, sir.
Thank you so much for having me. It was a pleasure.
Thank you so much, sir, for sharing your knowledge about blockchain, Bitcoin, digital transactions, and data economy with us. It was an amazing presentation full of zeal and valuable information, and we surely learned a lot from you. And it would be a great pleasure to listen to you again in our future events. Thank you so much for inspiring us and encouraging us. And in conclusion, I would now like to call upon Ayush Kumar to extend the vote of thanks. And sorry once again for the network issue.
Good evening, everyone. This is Ayush Kumar. It is such an honor for me to get the opportunity to thank you all. On behalf of IEEE, IT, and TESA, I would like to express my gratitude to all the esteemed delegates of the webinar for the presence and contribution to make this webinar a great success. I extend my gratitude to our honorable speaker, Mr. Rohan Sharan sir, to take out time from his really busy schedule to present such an informative and knowledgeable session. Even all the topics, all the things that he discussed, it really awared us about so many things about blockchain, about the things that is going on in the world. Another topic that is going in the development field, all the apps and all the online applications and all that, about what he discussed. It was really thankful to you, sir, that we get a chance to know so much about all these things. I also extend my gratitude to Dr. Dipali Saleh ma'am, faculty coordinator of our club, to organize such an event, to reach out to Rohan sir for conducting this webinar. And most importantly, I must thank the volunteers for working hard for the past few days to make this webinar successful. And finally, thank you to all the participants for their active participation. Thank you.